3.2 Errata. So I made a small error at this point in the problem when I was calculating the limit as x approaches 1 from the right here. So this is a mistake. Right? It did not impact the solution of the problem. We got an answer of 2 here for the 3 times 1 minus 1, but that's really not what should be going here. And the reason is this. So as x approaches 1 from the right, we look at this limit, and certainly we're on the right-hand side of 1, so therefore I should be using f of x as being the 3x minus 1 piece of this function, as we described before. That's what's happening on the right here. Right? 3x minus 1 is what the function looks like as x is to the right of 1. And that's what the limit is considering, specifically when x is approaching 1 from the right. But nevertheless here, f of 1 itself is actually evaluated in the 2 root x part, because when x is 1, right, we apply this part of the rule to these values. So therefore, even though the value ends up being the same, 2 root 1 is of course also 2, that didn't have to be the case. It's not always the case. It was only the case that it was the same result here because this function was continuous at this location. But really, if it hadn't been, we'd have a whole different answer. So it was just contextual that it worked out to be the same. So really, what should go here is 2 root 1. Right? That is actually f of 1. And again, even though it's the same value, even though 3 times 1 minus 1 is the same value, that is really not what goes here. Right? So again, the limit is as x approaches 1 from the right, so this function must be whichever part of the piecewise function has x values to the right of 1 associated with it. When you're calculating f of 1, it is not dependent upon what you chose here necessarily. Just look back at the original function and see what piece you should plug the value of 1 into, and that will be the particular expression you want here, not necessarily the same as this one.